So hi to all of you that joined. Hi, Vitaly. We will wait a minute just to let everybody that wants to join the possibility to do it, and then listen to everything that is going around. We do have people from all over the world, so we will do that in English. And we are very excited and happy about that we can provide this topic to people globally. So it's 2 minutes past the hour, so I think we will start. And this session is being recorded, and we will upload that once the session will be over. So if you joined in the middle, you will be able to see it after. So first of all, welcome, and again, thank you for joining us. And we know it's morning for most of you, so thank you for joining us in your morning and throughout your working day. Hopefully, you have some coffee and snacks for this session. So just a quick intro. We are takeaway.com or Just Eat Takeaway. We are a global company focusing on the food ordering delivery platform, working from a couple of development centers throughout the world, or currently in Europe. So we are talking from sunny Tel Aviv, and we have a very big development center here, but we also have centers in Berlin, in Enschede, which is a city in Holland, and in Bulgaria. Also in Just Eat, we have some development centers in the UK. And important note, we are hiring for a lot of vacancies. So if you would like to hear more, just go to takeaway.com/careers, or just Google careers at takeaway.com. So that's from my end. Vitaly will take the lead now, and then go through server-side rendering, and we'll also talk about a bit about the 10bis story about us, how we were able to implement server-side rendering, why we did that, and why we even dropped that at the end. So thank you, and hope you have a good and productive session. Vitaly.
Yeah, thank you, Tomer. Okay, so we are going to talk about server-side rendering and the different alternatives to it. It's a very popular topic right now. Everybody are doing it right now, essentially, because we will see why. Yeah, so that's me. I have 8 years of experience in web programming. I lead teams currently in 10bis, which is the takeaway.com's Israeli website. I use all these technologies in production. I use it right now in different projects I work on. And also I have a blog in Medium, so subscribe, it's really, really nice. Okay, so we will start with client-side rendering, because I think it's something that most of you are familiar with, and it's the easiest one to grasp. Then we will move to static site generation, server-side rendering, and then we will see another solution, dynamic rendering for bots. Yeah, so that's the agenda. So first of all, what is rendering in general when we talk about client or server-side rendering? When we talk about rendering, it's not the browser rendering, it's not React.js rendering, and there are a lot of renders in web development. This word is probably abused. When we talk about server or client-side rendering, we talk about the generation of the initial meaningful content of a web page. So for example, I have a homepage. Okay, I have this homepage here. Now the question is, who generates the HTML or the DOM that in the end the user will see and interact with? By the way, if you have questions, just go to the question bar and just ask, and I will probably answer it between slides or something. So yeah, so we talk about the generation of the first meaningful content of a web page. Now, in client-side rendering, it's very, very interesting because in client-side rendering, we don't actually generate meaningful content on the server at all. The user only receives something like an initial loading or something, and the user receives his the body of his HTML. It's just empty, right? Like here. And then one of the libraries, or Alex, if you can't hear me, just reconnect, I think. I believe most of the people can hear me, so it's probably some kind of weird problem. So that's how client-side rendering works. I think most of the people used it like this. This is how, for example, create React or Angular app works when you create like the initial version of both of them. And here is an example. So in this example, that's the AngularIO website, okay? And now, obviously, the website is beautiful, right? It's very useful and all. And it's client-side rendered. They don't use any server-side rendering technologies. This is client-side rendered, which means that when you navigate to this web page, what you initially receive is this empty body here. You only receive this tag. And also your title is generic, which means that it's the same title for all the different pages. So here I navigated, for example, to the glossary. I'll show it again. This is the glossary where you can just find any term of AngularIO by looking at one of the letters of the alphabet. So, but it doesn't say Angular glossary. It only says Angular, because in client-side rendering, you receive the same HTML for all the different pages. And this is how it looks if you navigate to the preview tab in your Chrome or one of the other browsers. You can actually preview the content of the page that you receive. Christian, we will talk about why people choose server-side rendering. It's not only for SEO. There are other legitimate reasons. Okay, so that's how a web page looks like when you receive a client-side rendering. And obviously, after your framework, Angular or React or whatever you have on your web page runs, the body is expanded, and it looks like this, and it shows the whole website after it's expanded. Now, as you can also see, the title is also expanded. The title is also, it becomes meaningful only after JavaScript ran, only after the framework actually downloaded the content of the web page, handled the route, and it shows us the meaningful title in the end. And client-side rendering is nice in many cases, and it's very, very useful, but sometimes it's not enough. And we will touch the 3 points where client-side rendering can go wrong. Obviously not always, but sometimes. We will see why link previews, SEO, and performance might not work really good in client-side rendering. So first of all, link previews. Now, link preview is what happens when you paste a link into one of the many platforms that you use every day. For example, here in medium.com, I pasted the AngularIO/glossary, but it doesn't show me a specific content to the glossary. As you can see, the title is just Angular. The same happens in Reddit. No glossary here. The same happens in Facebook. You see the preview only shows the Angular. Same for WhatsApp. In Twitter, it doesn't even show any preview at all. And the reason for that is that because when you paste a link, the platform has some kind of robot that navigates to your web page, and it just takes the first title that it sees. It doesn't actually run the JavaScript. It doesn't actually let it expand and all, and it only shows the first content that it received. Now, we don't always care about previews. For example, AngularIO, as we saw, they don't really care about the preview that will be shown when someone links to their documentation, okay? It's perfectly legitimate. They don't really care about it. But in Tenbis, for example, in Takeaway, we have this beautiful restaurant here, and this is how a preview looks like, okay? We want the preview to be kind of seductive. We want people to click on it. We want people to see something beautiful here when someone links to our web page. So we don't really care about link previews if we are behind a login, which means the content is private, because how are you going to link to something that's private, right? Same with dashboards and studios and non-commercial websites like AngularIO that we saw before. But we do care about all the things when we link to public pages, for example, home pages, or in this case, something like products. Also, if we have a content-based website, like blogs, news, videos, all the things deserve a beautiful link preview. And also, it can really improve your conversion rate. Imagine if I linked this link and the preview wasn't generated. People might think that it's some kind of scam or something even sometimes. But here you have a beautiful picture, you have this description, and you will probably be really happy to click on it. Okay, so that's one point. Now we move to the second thing that might be problematic in client-side rendering, which is SEO. SEO is super important in websites because the higher you get in Google, the more traffic you will have, and it's free traffic, right? You don't pay for it because it's like, we call it organic rank. Because the better Google ranks you, the more traffic you will have even without paying Google. So something that is very important for a lot of companies. And as we can see, even other search engines, not only Google, they can actually deal with client-side rendered application. So this is also sometimes surprising for people, that Google actually goes to your web page, it actually renders it, it waits for all the JavaScripts to run, and only then it ranks your website. Okay, so that's a very important thing in SEO. So looks like client-side rendering might actually be enough, but it isn't, and I will tell you why. Okay, it's not enough because we have this short route to be rendered. Okay, in the short route, Google navigates to your website. It receives a web page. Okay, now after it receives it, it parses the HTML. It looks at the page and ranks it. Then it looks at all the links that it received and it scrolls again. So that's like the happy path. That's like the short path. And now we have to ask, what happens if the HTML is empty, right? So if the HTML is empty, you need to wait in queue because Google has a limited number of resources, and Google needs to assign these resources to the different web pages that it wants to rank. So you need to wait. Now, how long do you need to wait? Something like a week, or maybe a month, or maybe 2 months. It's really a huge question, and it depends on the size of your web page. It depends on many factors, but you need to wait anyway. And then Google renders you on their machines, and it takes the DOM that it rendered, and it indexes you again. Okay, so that's how SEO works. That's how search engines work. Sorry. And sometimes client-side rendering is enough, right? Again, Angular.io, why didn't they implement some kind of server-side rendering solution? Because they don't really care to wait in this queue. They don't really care to wait 2 weeks before being rendered. But sometimes it's not enough. First of all, because Google receives this empty page at first, you will not be indexed right away. Maybe you will even receive a bad, maybe Google will even index you in a bad way. Like it will index you based on this initial empty HTML. So that's one danger. Another thing is that you need to wait in queue in order to get indexed. And it's problematic, for example, for news websites, like if I'm CNN or something. When something political happens in the world, I want people that search for it in Google to find my webpage right away. So I want to work in this happy path. I can't allow myself to wait 2 weeks in queue, right, until my webpage gets indexed. And also, because Google renders your website, it's not clear how good it will render your website, because it can go wrong. And if it goes wrong, you need to wait 2 weeks again in queue until you can check again how Google rendered your website. It's much better today because Google used to render your website on Chrome 42 or something, a very old version of Chrome, and it was a huge problem. Like this rendering was like problematic. Nowadays, they render your web page on the newest Chrome, which is a huge improvement. So actually, the long pass becomes much more viable. It becomes much more legitimate to choose client-side rendering, because you can actually rely on this render many times. But again, the question is if you want to wait in this queue. That's I think the most important question that you need to ask yourself. Daniel Krosner asks, Google experts claim that their robots are getting better and better in understanding JavaScript. Yes, that's very, very important. It's true. Like, yeah, when Google renders your website today, it would probably render it correctly. So this part becomes much less important. The main question is if you want to wait in this queue. Also, for example, if you have a lot of links and you want Google to crawl all these links, if you will wait a week for every other layer of links that Google crawls, it also might be problematic. But usually, I think the most important thing is the waiting for rendering resources. Google renders your web page pretty good today. Performance. Okay, so that's the third thing that we want to discuss about client-side rendering. Now, we again talk about Google because Google is like everywhere in performance and SEO and all the things. Google are like leading, so and they lead in performance measurement for sure. They have this tool here, Lighthouse. sorry, they have this tool here by the name of Lighthouse, Google Lighthouse, and it measures performance really, really nicely. I mean, you have all this information that you can use in order to improve your user's experience, and I encourage you using it. We implemented it in 10bis, or we are implementing it in 10bis right now because it's very, very useful for us. I will not talk about the different metrics here, although they are very important, all of them. I will only talk about this one and another one later. So Google measures how much time it takes to show the first contentful paint on your website. Usually it's like an image or a small text or something. That's the first contentful paint. And it's super important for user experience because the moment the user sees something on the screen, the user already feels that, okay, something happens. But the more important metric is largest contentful paint, is when the page is actually being seen, is when the largest part of the web page is actually loaded. For example, in this case, is this image here. And I will call this metric time to see content or something like this. Time to content visible, right? I will not use LCP because it's like too technical for us. I will just say time to content visible. And in client-side rendering, time to content visible tends to be kind of problematic, especially if you work with older devices and especially with mobile devices. Because in order to show the content, the user, when they navigate to your web page, they need to download all the different JavaScripts that you have, all the frameworks and all your code. Then it needs to run it. Then it needs to make all the AJAX calls in order to receive the content that you want to show on your web page. And only then, after all the things happened, the page is being visible. So usually you have this process with loadings and with skeletons and all the things that are meant to improve the user's experience. But in the end, it takes time to show the content. It's not a problem though, if your users are using strong computers and they have good connections. For example, AngularIO, right? AngularIO, their web page, their documentation, who navigates to this web page. Usually it's developers with really strong computers, good internet connection and all. They don't really care about mobile devices. So, okay, but in news websites, when a lot of people navigate to your website from slower devices and sometimes even from trains and maybe from an elevator or something, you want to send them all the HTML right away, probably, because you want them to see the content of the web page as fast as you can. Okay, so we saw 3 problems with client-side rendering. Again, it's not always a problem. It depends on your website, but it potentially might be a huge problem, right? If you really want link previews, it's maybe surprising, but you can't do it only with client-side rendering. For example, same goes for the other 3. Let's see some solutions to these problems. First of all, before we go to server-side rendering, which is probably the most famous one, I guess, prominent one, let's look at static site generation. In static site generation, in build time, right? So I just run something like npm build, and what I receive is all these different pages already ready for me to serve, okay? And I just upload it to some kind of CDN or something, and it's just there. So the user wants article 1, no problem, I generated it in advance. I just serve the user the article. For example, in this homepage HTML, you will have the homepage, right? You will have all the content of the homepage. And how do you achieve it? Well, in React, you have render to string, which is what Next.js and Gatsby use. Also, there's some variation. You can render in stream and stuff, but I will not talk about it in this lecture. You can also create a client-side rendered application and use a headless browser or JS DOM. So use some kind of simulation of a browser to run on all the different routes and render them. Okay, now it's a little easier than the first solution because you only implement a client-side rendered application and you do like one extra step where you render everything in advance. But I think it's more buggy. It might be a little more problematic, the second solution. It's less robust. Also, that's the solution that frameworks that are not even using JavaScript use. This is how usually blogs generated and WordPress and all these other solutions that we don't really use in JavaScript world. Okay, so here's an example in takeaway.com. Sorry, in Takeaway Pay, takeaway.com/takeaway pay that we built here in Tel Aviv. What we do is that we create something like 30 or 40 index HTMLs in advance for every combination of country and language. And we do it in advance, right? Why do we do it? Because we want to serve, or like if someone navigates to the English version, we want to serve them the English version right away. So we hold all these 40 versions. When someone navigates, if we go to the preview tab, we see all the content right away. Now it's great for previews. It's great for SEO. It's super fast. So that's the solution that we use. But there's a small problem with these solutions and with SSG in general. It's called time to interactive. And the reason for that is that once the user received the HTML, right? The HTML is generated in advance, we said. So the user received the HTML, but there's a small window when the user can't interact with the web page. So for example, I have this menu here, right, in CNN. And if you go to CNN and you slow your web page significantly, you will see it. You start clicking on the menu and nothing happens until JavaScripts actually ran. They attached themselves to all these buttons and all these features, and only then it works. Why it happens? Because something that's called hydration. Hydration is a very, very important term in everything that's not client-side rendered, because hydration is the process of attaching JavaScript to a web page. Now, let's say we received this homepage from the server. Okay, so we have this homepage already and the user sees it. Now the browser has to download all the different JavaScripts, if it's not cached, obviously. If it's cached, then we skip it, but the user has to download the JavaScript of the homepage. Then it needs to run, and only then this HTML will be converted to something that actually works for the user and the user can interact with it. In React, we have a React DOM hydrate. In Angular, we have with server transition. And we can also use something like jQuery. It's a similar concept because jQuery attaches to your web page. For example, it goes to this button and attaches to it and makes it useful. And in terms of performance, SSG is very, very fast because we receive all the HTML right away. The server generated everything in advance, we just receive it. So time to content visible is very fast, but time to interactive might be problematic. It's like on our webpage, on our website in Tenbis, when we used SSR, which is similar in the challenges of time to interactive, we didn't actually have this problem because our scripts were kind of small and very fast. So the user received the content and the JavaScript ran pretty fast and everything worked pretty good. But sometimes it's a huge problem. Like if your user navigates to your web page and starts to click on something and it doesn't work, not only it's a bad user experience, also your users might think that something is broken. They might actually leave the web page, which is devastating for your conversion rates, especially on slower devices. If you know that your users use slower devices, you need to be much more careful about time to interactive. Okay, so what do we choose? Do we go with client-side rendering or SSG, static site generation? In terms of SEO, if you can allow yourself to be queued, if you don't care about it, then client-side rendering is good enough. But if not, you must use a different solution. SSG is one of them. We will see more. But client-side rendering is probably not for you if you don't want to be queued. In terms of link previews, you can't solve it with client-side rendering alone. So SSG is the solution here, because the bots of the preview will receive all the content right away. They will be able to generate all the previews. And in terms of performance, it's a little more interesting, because if you really care about content visible, time to content visible, then SSG is better. But client-side rendering is better in time to interactive. Why? Because in order to be interactive in client-side rendering, in order to show content in client-side rendering, you have to download and run all the JavaScript, all the script. So the page will be visible at the same time as the web page becomes interactive, because by the time it's interactive, all the JavaScripts already ran. Maintenance is much lower in client-side rendering. And actually, it's like the last point, and they didn't talk about it much, but it's super important, because if you're a small company, it's harder to use server-side generation or server-side rendering or one of the other solutions. But client-side rendering is the easiest one to start with. It's the easiest one to just develop. We will see a lot of challenges in server-side generation and rendering later on. But in general, the fact that it's easier to work with client-side rendering is a huge advantage that it has. Another thing you can do is just don't use JavaScript. Now I know like 95% of us can't really implement something without using JavaScript. But here on my webpage, I only have HTML. So no JavaScript, no problem, no bugs. I have a really fast time to content visible, really fast time to interactive, and Google really likes this solution. So if you can remove JavaScript, just do it. Okay, so we saw why SSG is great, and SSG is indeed great, but now we will see a drawback that it has. Okay, so why not SSG? Let's say I have, sorry. Okay, let's say I have a news web page. Okay, so let's say I'm CNN. I probably have thousands of articles, right? So let's say I want to change the footer just a little, just move something small on something that's that all the different web pages use. The moment I do it, I have to regenerate all these web pages. So it's like 100,000 of web pages. Think how much time and how much bandwidth and how much computing power it will take. It's actually pretty crazy. It goes in, it becomes not viable really fast. So SSG, so that's one of the drawbacks of SSG. You have to generate everything in advance. And here is when we move to server-side rendering. Now, server-side rendering is very interesting. Server-side rendering is kind of like SSG, but instead of building all these web pages in advance, what we do is that we build to a server, and the server holds our application. Let's say it's like a React application or Angular application or whatever. And only when someone navigates to the web page, it actually generates the web page for the user to be shown. So if I have an article from 95, it would probably not be generated at all because no one will even navigate to it. But if someone navigates to article 2, let's say it's a very new article, very hot article, someone navigates to it, the server generates the web page and sends me the web page, and also it caches it. Now the cache here is very important because the moment the server caches article 2, when someone actually requested it, the next user that will navigate article 2 will receive the web page from cache. And it's a huge advantage that it has. Now, older articles can still be served if someone explicitly navigates to them, but usually people don't navigate to them at all. If you have questions, ask. This is kind of a hard concept, I guess. Although I think the team in Amsterdam uses it, so you're probably familiar with it. Another thing about server-side rendering is that in modern frameworks, especially in React, Angular, Vue, all these modern frameworks, what we do is that we use the same application on the server and on the client. In React, it's very, very easy to show. What we do is that on the server, we render to string. We take this application, this React application, and we render it to string, right? And we receive the web page itself. Then we go to the client and we render the same thing on the client. And that's how we get the hydration, because what we render here basically attaches itself to the result that was rendered on the server. And we will see some challenges with it very, very soon. It's also kind of similar to PHP, to those who worked with it, because the PHP just sits on the server, and when someone navigates to it, the PHP generates the result for the user. It also can be cached, right? And then on the client, it usually runs jQuery instead of how we use it in React and Angular. What tech stack you're using on server side? What for cache? So Next.js is great with it. Gatsby is Gatsby is SSG. I think Next.js leads the way now, and also custom implementations. That's the best ones for server-side rendering, I think. Okay, some benefits in server-side. So let's say the user navigates to this blog post. Okay, blog post page 2 or something, okay? So the user will see the web page faster than in client-side rendering, even if it's not cached. Okay, let it sink for a moment. Even if it's not cached, the user will see the content faster than in client-side rendering. Why it happens? First of all, if it's cached, then the user just receives the HTML right away, right? Because the server already has all the information ready to be served. But if not, then still the speed at which the server will be able to render the web page for the user is faster than in client-side rendering. First of all, it's because the application here is hot, right? It's already on the server, it runs, you just give it parameters and it spits out HTML. So it doesn't have to download the JavaScripts, doesn't have to run the JavaScripts, doesn't have to run the JavaScripts. It's just there, ready to be served, okay? Ready to generate HTMLs. Also, because the server, when it makes requests to the API server, so we have two servers here. One generates the HTML and one is the API server. When it makes a request, it's much faster because these servers are closer. Also, for example, it can be the same server. In many places it is. Like this server can make database queries, for example, and using these queries, it can serve the web page. Also, you can implement smart caching there, and it becomes pretty complex many times. But in general, even if you generate a new web page for every user on the server, it's faster than client-side rendering because the servers has probably better CPU, probably faster AJAX, and the result that the HTML returns compressed. So even this is not really a problem. Okay, performance in SSR. So in terms of how much time it takes to see the content, if the content is cached, if it was served before, then it's super fast. If it's not cached, then it's better than client-side rendering. It's a little slower than just SSG, right? Because in SSG, you don't have to work in order to serve the pages. You build them in build time. You generate them in build time. Here, you generate it on the server. So it takes a little more time, but it's still faster than client-side rendering. And time to interactive, just like in SSG, it can be tricky. It can be problematic. It's something that if you choose one of the solutions that are not client-side rendering, you really need to tackle. You really need to make sure that it works all right. Okay, now we move to dynamic content. Now, this is where the non-client-side rendering solutions become kind of tricky, because let's say I want to show this dynamic content here. That's like my name. That's Hi Vitali, right? So I can't achieve it in SSG. Like I can't return this exact HTML from SSG because it has dynamic content on it. It depends on the user, right? So that's one thing. And the other thing is, imagine yourself, I want the order of the items here to be based on the user, right? For example, I have some kind of third-party service that provides me with information about the user. I have an AI on my server, something like that. And I want the items here to be sorted individually for each user. So if I navigate to this page, for example, I will see the more expensive things at top because some third-party service contacted like the web page, and my server contacted some third-party service, and it inferred that I like to buy expensive stuff. Okay, so I want to show the expensive stuff first. Can I do it with SSG? Well, not really. I mean, what you can do in SSG is like a two-step initialization. Sometimes it's called a shell initialization, because you serve a shell. You serve your web page without the content, the dynamic content, sorry. And then on the second step of the initialization, suddenly the content appears. You can also add like skeletons and loadings and all kinds of things that make it more beautiful. But in general, it's like a two-step initialization. Regarding the order of the items, it's pretty problematic. I mean, you can render in SSG, you can render just skeletons, right? But it's not the same as serving everything right away. It's just not the same. But it's a legitimate solution. Like you can use it because it might be very useful. You can also use both of these solutions in SSR. Now, why would you use them in SSR? Why would you initialize in two steps? I'm talking about this solution, right? Where things appear like this. Or, by the way, if I'm not logged in, It will appear like this, okay? Why would I use it in SSR? I would use it in SSR if I want to cache the web page regardless of the user. Okay, so even in SSR, I can use the two-step initialization solution. But in SSR, I can actually serve everything just like here. Okay, I can, when the user goes to my server, I can actually log in the user, build an individual HTML for this specific user, and serve it. So I can actually achieve the order of the items in SSR. I will show it. Okay, so yeah. It means that we have several challenges in SSR and SSG. Okay, I have a question from Philip before that. When doing it in two steps, we don't have a problem with other content rendering on server side and other on client side. Yeah, Philip, that's one of the challenges. So if you want to use this solution when things appear in two steps, you need to make sure that when the hydration runs, the hydration is for this version. And when the hydration finishes, only then the dynamic stuff starts to happen. Okay, so it's challenging. It's not an easy solution, but you can actually do it in SSG. So that's what's nice about it. Okay. In SSR, it's also a little hard because you need to log in the user on the server. Like on this step, when the user requests the web page, you take the cookies of the user, you log him in, and you spit out special HTML for them. Usually it means that you give up on some of your cache also. So it's tricky. Dynamic content is tricky in general in these solutions, in SSR, SSG. And that's one of the challenges of SSR, SSG. First of all, when you hydrate, you need to make sure that your client-side rendering and service, sorry, that what your server renders, the HTML that you initially receive, is exactly what the client expects it to be, right? For example, this is like a classic example in that makes a small flicker. If you use math.random, here you will receive one random value. So the HTML will return, for example, with 0.3. But when you hydrate on the client, you will run the application again. You will receive another value. So you will have a flicker. Now, flickering is not the worst thing that can happen, but it slows the website. It doesn't look really good, especially if you have a big flicker on your web page. Also, it can get you into broken applications. It can actually break your application. So it's a huge challenge. I can tell you that when we worked with Next.js, with SSR, we almost didn't have this problem because we were really careful, because we had a really good infrastructure there. So it might be very challenging, but if you work correctly, it won't be. Caching. So caching is one of the hardest two things in computer science. That's what Phil Carlton said. The second thing is naming things, right? So the moment you implement SSR, you will see that caching might be really useful for you. And then you will see that it's really hard to invalidate it. What happens if we, I don't know, when we update versions, when we update only some of the pages, right? So it becomes tricky. Dynamic content. So we saw that whether you do it using the two steps in initialization, whether you create the dynamic content on the server in SSR, in both cases, it can be tricky. It can be challenging. In client-side rendering, obviously, you just you just do it in one step of initialization. much easier. Also in SSR and SSG, you get to bigger infrastructures. Now it happens because suddenly you have to have a server that renders the web page for users. And now you need load balancers. You need to understand who makes the requests to the database. You need to make sure that your cache is invalidated in the right places on all of the servers, for example. So it can get really can get pretty tricky. Also, you need to find a way to log everything. You need logging on the client and on the server. You need to find a way to debug on the server and on the client. Also, you need to deal with prices because rendering things for the user might get expensive. Documentation, training, bugs, bigger infrastructure means that your teams need to deal with more work usually. Okay, so the previous solutions were complex, and now we will see what we did in 10bis just a few weeks ago. So what we do in 10bis, it's called dynamic rendering for bots. And what we do is that when a user navigates to our website, the user sees the website as a client-side rendered application. Okay, so it's just a regular application. The user receives an empty body, and React.js expands it to be 10bis. Okay. When a bot navigates to our servers, it goes through another step. It goes through rendertron. It goes through a headless browser that renders the web page for the bot and serves the bot a meaningful content. So the bot actually receives all the HTML right away. And it works really nicely for us. And the big advantage in this solution is that not only we have very nice link previews and we don't need to wait in queue in SEO, also it's much easier to do than SSR and client-side and SSG. And we don't need to maintain all this big infrastructure. We don't care about it anymore. Okay, so that's why we decided to move from SSR to this solution. And this is how the website looks for users that navigate to it. They only receive like a loading, okay? Only receive an empty body like here with a small loader. And after a moment, this whole beautiful website is served, right? So, sorry, this is what bots receives, I mean. The bots receive this whole web page right away. So when a bot navigates to us, we serve him the web page right away. We differentiate, yeah. Lakshmi asked how we differentiate between bot and a human user. So in this step, we look at the user agent of whoever requests the website, and bots has a special user agent. There's the word bot there. So whether Facebook comes to us to generate a preview or Google comes to our website to index some page, we look at the user agent and decide if we want to serve them like this version or this version. Okay, so that's how bots see the web pages right away, right? The users see it like this, and the bots receive meaningful content right away. I will talk a moment about hybrids. So obviously, if you didn't understand anything, I almost finished the lecture and we have like 15 minutes left. So it's a lot of time. Anything you didn't understand, just ask. So I have a hybrid example here. I use client-side rendering with server-side generated headers. Okay, so in build time, in this example, what I did is that I only generated the headers, okay? it's much easier than generating the whole body, and you don't really need to care about hydration as much, because you can just hydrate the body, but you can ignore the header at all. So what you can do is that in build time, you generate the headers, and then you will have link previews, right? Because link previews depends on the title and the description and the different tags on the in the head section. So link previews will work. You will rely on Google for indexing, which means that Google needs still to navigate to your website, and to you will need to wait in queue, and it will take like 2 weeks and all of that. But you can say that you don't really care about that, but you still want link previews, right? It's a legitimate solution. It's actually a very nice solution. And also user will receive everything as client-side rendered. So it's easier than SSG because you only generate the headers, but you still benefit from meaningful headers here, so link previews will work. Also, you can create very complex custom solutions. So if I go to here, for example, so I can say that this whole part here is like SSG, but the small part here is SSR, for example. Or I can implement some kind of very complex caching that caches the page as a template and only generates this small part. So there's a lot of complex things that you can do. But again, you will see that you will need more documentation, you will need more training, you might probably have more bugs. So it all comes down to trade-offs, right? Like any architectural decision. Okay, so we saw this hybrid here, and now we come to the summary. Client-side rendering. Time to content visible is the slower, but time to interactive is the fastest. SEO, you rely on their rendering, and you need to wait in queue. Link previews doesn't work unless you do something like this, right? This is actually like the one thing that you can do to make your client-side rendered application to be useful with link previews. And the infrastructure is and the maintenance is the smallest of all the solutions, which is the huge advantage of client-side rendered applications. SSG, time to content visible, is very fast because you generate everything in advance. You have all the HTMLs, just need to serve them. Time to interactive might be tricky, not always. It might also be seamless to the user. SEO, you have full control. You don't need to wait in any queue at all. Link previews works because the bots received the headers with like meaningful headers for all the pages, and the maintenance is relatively complex. SSR, time to visible, is above average for most of the users. It's faster than client-side rendering. Pages that are cached are just like SSG. Time to interactive might be tricky. SEO, like in SSG. Link previews also like in SSG. So you have the head section populated and the body section also. Infrastructure here, I believe, is a little more complex than SSG even. I think some people don't agree with me. Some people say that SSG is more complex, but I think SSR is more complex because of the caching that in the end you will want to implement. And the last solution that we saw, dynamic rendering for bots. So it's client-side rendered for users, right? So it behaves just like a client-side rendered application. So time to content visible is the only drawback of this solution, because it would take some time for the users to see the content. But time to interactive is very fast. Your SEO is also very good because Google receives everything, all the meaningful HTML. Link previews also works pretty nicely because also the same reason. And the infrastructure is just a little more complex than client-side rendering. It's a client-side rendered application with one more small step. Okay, it took me like 3 days to implement this small thing that I added. Okay, so what do you choose in the end? It really depends on your application. If you're a small startup, you probably want to go for this one or this one. You might want to use this hybrid solution maybe. If you have dynamic content that you want to show to the user and serve it from the server, then SSR is the best one, but it will be more expensive. SSG is really, really good if all your web page is public and you don't have too many pages. So it all depends on your application in the end. Okay, Christian asked, with SSG or SSR, do you modularize somehow those rendered pages? Head parts, script tags. What do you mean modularize? I don't really understand. What modules are you talking about? Okay, so I think that's the only question I have. So if you want me to clarify anything, just write in the questions. Otherwise, I think we finished. Okay, templates for HTML pages is also a very good solution. Show it briefly. So that's, for example, how these solutions work. Okay, what they have is just a template generator, and you give them the content that you want to show, for example, in your blog, and they spit out the HTML for this page. Okay, so templates for HTML, for generating HTML is very useful in probably in all of this. For example, in SSR, what you can do is you can cache the web page besides the dynamic part. Okay, so for example, in this page, I can cache everything. I can cache everything besides the top part. And when someone asks me to serve the page, I only change this small part based on the cookies of the user, and that's it. I serve the web page. Okay, so you can do it, but it's harder. It's not trivial. It's harder, but it's faster and probably cheaper and probably looks very nice for users. But again, like with complex solutions, you need to document it, right? You need to make sure that the code is written nicely for users, for people to understand how it works. So training, it might be also buggy because it's not a solution out of the box. Also, I think there's a security concern here, because if you use ready solutions, then you're probably more secure if you just use plain Next.js. If you do something custom, then you need to make sure that there's no security issues there. Okay, so there are no more questions. So, okay, there's one more question. What languages do you use on the server? Node.js? So yeah, you use Node.js because of this. Because if you have an application that's written in JavaScript, you want to run it in JavaScript, both on the server to generate the HTML and both of the client to attach to it. And the huge advantage here is that you write the application only once. You don't need to write like a separate engine to generate the HTML and the separate engine to hydrate and to run on it. Okay, so because you use only JavaScript, you want to use Node.js. What do you use for cache? Redis? Yeah. That's the different options, I think. That's the most popular options. Okay, thank you very much, guys. I really enjoyed the lecture. If Tomer is here, might want to say like a few words. If not,
How do I unmute myself?
okay, Tomer is here. That's great.
So, yeah, can you hear me, Vitaly?
Yeah, I can also see you.
Okay, perfect. So, yes, so thank you. I know I learned a bunch here. So thank you for that. We will share this. We will post it on our LinkedIn, and also we'll send out an email there stating or sharing this session. So you will be able to share it with your friends and colleagues. We do plan to have more sessions like that, so please tune in to our mailing list. And thank you, Vitaly, and thank you guys for attending.
Thank you very much.
Bye-bye.
Bye-bye.